Hello guys, so we are back again, and in this session we are going to do another part of second and third order higher order derivative problems, as we have discussed in the few lectures. Okay, 3 to 4 lectures, many varieties of second and third order derivatives. So we are going to add on some more varieties to this. It is going to take some more 2 lectures. Okay, then we will end up this section of partial differentiation. So before starting with the session, as I mention in every video, don't forget to subscribe the channel. Your subscription means a lot to us. Okay, it will help us to bring you more content so that you can secure a better marks in your engineering examination. Now let's take the first question, which is as follow. If u equals to z into tan inverse y by x, then find the value of dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square. Okay, let me check whether the question, okay, find the value of. Now what you have is u equals to z tan inverse y by x. What we are going to do, partially differentiate u with respect to x. What you are going to get, dou u by dou x equals to z into 1 plus y square by x square. If I differentiate it, minus y by x square, which will give me minus this, and x will cancel out, minus zy by x square plus y square. So we are getting this thing, but what we want is, we want with respect to x again. So I will call it as 1 and do what, partially differentiate u with 1 with respect to x again. The moment I do, what I'm going to get is dou square u by dou x square, which I will call as dou by dou x into dou u by dou x, right? And if I simplify, what I'm going to get is x square plus y square the whole square into x square plus y square, right? And here, if I differentiate it with respect to it, this will become 0, and I have kept minus outside. We are applying quotient rule. Now zy will be outside, and we are going to differentiate with respect to x. What? X square plus y square, which will give us, this will be 0, minus zy 2x by x square plus y square the whole square. Okay, which will be minus 2xyz the whole by x square plus y square the whole square. Now call it as what, 2. Now similarly, what we are going to do, partially differentiate u with respect to y. Now you can have one doubt that why we are not doing this thing, that similarly we can prove this. Okay, because it is not a symmetric function. Okay, so partially differentiate u with respect to y. What we are going to get is dou u by dou y, which will be nothing but, if I differentiate it, it will be z by 1 plus y square by x square. This will be 1 by x, which will give me, if it moves up, it is going to be zx by x square plus y square. Okay, so we are getting this stuff here, which will be my 3. So what I am going to do in the next step is partially differentiate what, differentiate 3 with respect to what, again, y. Okay, so we are going to get dou square u by dou y square, which will be nothing but, if I differentiate it again, it will be dou y into dou u by dou y, which will be x square plus y square the whole square. It will be x square plus y square. If I differentiate it with respect to y, this will become 0, minus here zx will be outside and it dou by dou x into z x square plus y square, which will be probably minus zx into 2x the whole by x square plus y square the whole square, which will be minus 2x. And here it is what? X that cancel out. Okay, it was what? Y by x. Okay, so if I differentiate minus, okay, 1 by x is left, and no, there is no mistake, everything is perfect. So what we are going to get here, we are going to get this has become 0. I'm checking whether I'm doing any mistake or not. Zx, okay, when differentiated, okay, here z will be left, it will not be 0 because zx is there, and further here it will be what? 2x into zx square, minus 2 into zx square plus, okay, let me write in the next step. Okay, this thing is wrong. This will be what? Zx square plus zy square minus zx square 2, and here we are having x square plus y square the whole square, which will be what? Zy square minus zx square, giving us finally x square plus y square the whole square. Okay, now what we can do in this problem is that what is the last thing which we need to find out? We need to find out dou square u by dou z square. So partially differentiate u with respect to z. What we are going to get? Dou u by dou z, which will be nothing but what it will be? If I partially differentiate, it will be nothing but z 1 by 1 plus y square. And if you observe, this is a constant thing, tan inverse y by x, because if I differentiate it, okay, you can clearly see the function here z. Okay, you cannot apply product rule, it will simply become 1. After differentiation you will be left with tan inverse y by x, and the next step, when you partially differentiate it again, partially differentiate, okay, differentiate what? I will call it as 4, I will call it as 5 with respect to z. This is going to become 0, right? Now what we are done with, okay, all the three things we have, now we are going to add them. Add what? Add 2, 3, not 3, add 2, 4, and this is of no importance, 2, 4, and let's call it 6. Okay, so we have called it as 6 and 6, which is nothing but dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square, which will be nothing but, if you go on simplifying, minus 2xyz by x square plus y square the whole square. Similarly, this thing is what? This thing is minus zy square minus zx square plus by x square plus y square the whole square, and when they will add on, we are going to get what? Z, we are going to get something like, okay, let me check whether we have done any mistake or what. Okay, the minus sign will move inside, and minus sign will move inside. We are going to get what stuff we are going to get? This will become 0, this will become positive, right? This was negative, this negative side will move side, this will become positive, and I think we have done the minus sign mistake here also, or what? Let's check here. If I, no, there is no minus sign only here, so it was straightforward this thing, and it will be not, so it will be y square minus z x square plus 2xyz the whole by x square plus y square the whole square. Now if we take z common, I am going to get left with x square minus x square plus y square plus 2xy. Okay, something is getting wrong. Okay, there is something is getting wrong. Let me check again. Here we got it with respect to x. Okay, here there is sign is, everything is perfect. Okay, this is dou u by dou y. Then why we are differentiating? I think we have done a big mistake that we are differentiated with respect to x and it was y. So complete thing will be wrong, and if I differentiate it with respect to y, it will be x square plus y square the whole square into x square plus y square. This thing. Now further on, what we are going to do is that if there is no y term here, it is zx, so this will going to become 0, and here zx will be here, and it will be dou by dou x into x square plus y square. If I simplify, it will be minus zx, it will become 2y. Okay, since we are differentiating with respect to x, and rest will be x square plus y square the whole square, and if I simplify, minus 2xyz by x square plus y square the whole square. Now what we are going to do, write it as 4, and here this thing is correct. Okay, we have differentiated with respect to. Now if I put the value, this is what? This is minus 2xyz. So you can clearly see they both will cancel out and answer will be 0. Okay, so we are done with this problem, and let's take the next problem. Hope you have understand all these steps. Okay, we have done a mistake here, don't do that mistake. Okay, in engineering question mostly mistakes occurs. Okay, now so you need a practice, you need a lot of practice to avoid those type of mistakes. Now here let's begin with this question. Here, if x equals to r cos theta, y equals to r sin theta, prove that dou square r by dou x square plus dou square r by dou y square equals to 1 by r bracket dou r by dou x the whole square plus dou r by dou y the whole square bracket close. Now what we can see here, there is no theta in the first proof, and in the second, which is dou square theta by dou x square plus dou square theta by dou y square, it has theta. Now to get this proof, I need to eliminate theta from here. I know x equals to r cos theta, I know y equals to r sin theta. What I'm going to do, add square and add 1 and 2. We get what? X square equals to r square cos square theta, y equals to r square sin square theta. We are going to get x square plus y square equals to r square, and r will be nothing but under root x square plus y square. Now call it as 1. Partially differentiate. We need dou r by dou x. Differentiate r with respect to x. What we are going to get, dou r by dou x equals to 2 under root x square plus y square. Here it will be 2x, which will be nothing but x by r. This call it as 2. Partially differentiate 2 with respect to what? X again, which will be dou square r by dou x square, which will be r square r into dou x by x minus x into dou r by dou x, and I know dou r by dou x is this thing. I'm going to substitute that. This will be r minus x square by r, which is going to be r square. Finally I'm going to get r square minus x square by r cube. Call it as dou square r by dou x square. Call it sum 3. Okay, now let's move on to the next proof. Next thing, which is we need to find the same thing for what, for this y. But okay, but we can do one thing. We know r square is x square plus y square, so if I substitute here, my x will cancel out. I will be left with y square is equals to r cube, and this I will call it as 3, not this one. And now partially differentiate 1 with respect to y. What we are going to get? We are going to get something like, we are going to get, okay, with respect to x, we are going to get dou r by dou y. Okay, let me check the function. But this function is, okay, this function is symmetric. Okay, we don't need to do this step. We can directly write similarly dou square r by dou y square will be nothing but what? Since here it was what? It was y square by r cube, it will be x square by r cube. And dou r by dou y will be, it was x by r, it will be y by r. Okay, now what we are going to do, we are going to put these values in the given proof. If I put these values in this, dou square r by dou x square plus dou square r by dou y square, I am going to get a thing which is x square plus r cube plus y square by r cube. If you can see, this is nothing but what? X square plus y square. But x square plus y square is nothing but r square, and r by r cube, r square by r cube is nothing but r. Similarly, if I put these values here, it is going to be first it is going to be x by r the whole square plus y by r the whole square. Then it's going to be r square x square plus y square, 1 by r here outside, and you can clearly see it will get cancelled out because x square plus y square equals to r square, and I am left with 1 by r, so hence proved. So we are done with this problem. Now let's prove the second one, which is dou square theta by dou x square plus dou square theta by dou y square. How we are going to prove? Now I want in terms of theta. So I know x equals to, okay, I have space here, x equals to r cos theta and y equals to r sin theta. If I divide them, x by y will be what? Sorry, we should do y by x will be what? Tan theta, and I can get theta directly, tan inverse y by x. So I can directly substitute and get the answer. So if I want to get this, so I am going to do what? First find the value of, let me solve it here only. Okay, so differentiate, partially differentiate theta with respect to x. We are going to get d theta by dx equals to 1 by 1 plus y square by x square, and since it will be directly x square plus y square the whole by x square. Now call it as 3, partially differentiate differentiate theta with respect to what? X again or 3, you can write here 3 with respect to x again. So you are going to get dou square theta by dou x square, which will be nothing but what you are going to get here, x square plus y square the whole square, x square plus y square into 2x minus x square will be as it is, it will be 2x. So we are getting this thing. If I simplify out, I am going to get x cube, 2x cube plus 2xy square minus 2x cube the whole by x square plus y square the whole square. You can clearly see this and this will cancel out, and I will left with dou square theta by dou x square as 2xy square by x square plus y square the whole square. If I do it for d theta by dy, you can write it now again by yourself only. Now did we miss something, or we did any mistake, or what? Okay, let's check it out. I'm feeling that we are doing any mistake. 1 by y square by x square, and here we are differentiating it with respect to it, so it will be y by x square again with minus sign, and y will x will cancel it. I will be left with minus y. Okay, and minus y, since I am left with the differentiation of this thing will be 0, and the differentiation of this will be minus y by 2xyz. So my final answer is nothing but minus 2xy upon x square plus y square. Similarly, if I do this, I am going to get 1 by 1 plus y square by x square, and here, since with respect to y we are doing, it will be 1 by x, and if we move this, it will be x by x square plus y square. Now if I want to get dou square theta by dou y square, it will be nothing but x square plus y square the whole square, x square plus y square. What we are going to do here is, if we differentiate it with respect to this will become 0, but this part, which is keeping x outside, and dou by dou y, x square plus y square, this part will be remained, and it will be what? Minus x 2y by x square plus y square the whole square. Now and it was, now here you can observe one thing, it was minus, and when I subtracted it, it got again, so this will be plus. It will be plus. So we are doing a mistake a lot of it, and this will be minus, and after this, if I add 1 and call it some 3 and some 4, add 3 and 4, that is dou square theta by dou x square plus dou square theta by dou y square, we are getting 0. Straightforward. Now let's move on to the next problem. Hope you understand. Just don't do any differentiation mistake, then your answer will be right. Let's move on to the next question, which is, so let's begin with the new question. So the new question is, if z equals to tan y plus ax plus y minus ax the whole power 3 by 2, where a is a constant, then show that dou square z by dou x square equals to a square dou square z by dou y square. So what we are going to do, we have to write the z. Z is what? Tan y plus ax plus y minus ax the whole power minus 3 by 2. So what we are going to do, partially differentiate z with respect to x. So it will be dou z by dou x, which will be nothing but sec square y plus ax, and since we are differentiating it with respect to x, it will be a by chain rule. Further on here, it will be 3 by 2 y minus ax the whole power minus 1 by 2, sorry 1 by 2 will be left here, and here minus a. So what we are going to get is a, we are going to take common, we are left with sec square y plus ax minus 3 by 2 y minus ax the whole power 1 by 2, dou z by dou x. So what we are going to do in the next step, partially differentiate z with respect to x. Let's call it as 1 with respect to x. So we are going to get dou square z by dou x square, which will be nothing but, if I differentiate it again, I am going to get 2 sec y plus ax into sec y plus ax dot tan y plus ax into a, right? And here what I am going to get is minus 3 by 4 into y minus ax the power minus 1 by 2 into minus a. If I simplify this, I am going to get a outside, a square outside, and here I am going to live with 2 sec square y plus ax. Here tan y plus ax will be there, it will be plus 3 by 4 y minus ax the whole power minus 1 by 2. Okay, now we got this thing, let's call it as 2. Now what we have to find is this, to partially differentiate z with respect to y. So what we are going to do, z by dou y, which will be nothing but, this will be directly what, sec square y plus ax. There will be no a since we are partially differentiating it with respect to what, not x. Here we are differentiating it with respect to what, y. So it will be what, 3 by 2 y minus ax. There will be no a again. Let's call it as 3. Partially differentiate 3 with respect to y. So what we are going to get, dou square z by dou y square, which will be nothing but 2 sec y plus ax, okay, into sec y plus ax into tan y plus ax, and here we are going to get, sorry, this will be what it was, we started differentiating with respect to, here we got 1, okay, no issue. Here we will left with 3 by 2 into 1 by 2 will be there, and here we are going to live with y minus ax the whole power minus 1 by 2. Okay, so we are left with this thing, and here tan, okay, tan is there, there will be no a since we are differentiating it with respect to y. So 2 sec square y plus ax into tan y plus ax plus 3 by 4 y minus ax the whole power minus 1 by 2. So we got this thing. Now what we are going to do, here you can clearly see, okay, observe that this whole thing is same, just a is different, you can clearly see. So by observing dou square z by dou x square is nothing but a square times dou square z by dou y square, hence proved. Or you can write this thing equal to what, dou square z by dou x square. So it is proved that dou square z by dou y square is nothing but equal to a times dou square z by dou y square. Okay, so we are done with this problem. Okay, we are probably gonna do one more session of second and third order derivatives, and then we are going to end this section, okay, and begin with the new part. Thank you for watching the lecture. Don't forget to share it with your friends so that they can also secure a good marks in their engineering exams. Thank you.